How can we find the distance between a point and a plane? So take a look at this drawing here that I have. We have a plane, this green surface, and we have this orange point. And we want to find the distance between them. Okay? And I'm representing the distance between those two things with this orange vector. Now the great thing about this process I'm about to show you is that you can use it when asked to find the distance between a point and a plane, or the distance between a line and a plane, because all you have to do when you have a line is pick a random point on that line, and the distance between that point and the plane will be the same as the distance between that line and the plane. You can also use the following strategy when you're asked to find the distance between two planes. Because if you have two planes, you can simply pick a point on one of those planes and then find the distance between that point and the other plane. So whether you're asked to find the distance between a point in a plane, a line in a plane, or a plane in a plane, you can simply use this process by either taking that point or finding a random point on that line or plane and then following these steps. The first thing you want to do is you want to have the coordinates of your point. So let's say you have a point and we'll say the coordinates are x0, y0, z0. So those are three numbers that you have. Those are the coordinates of your point. Then you have a plane, and you have the plane written with the Cartesian equation, otherwise known as the general form. Okay, and the general form looks something like ax plus by plus cz plus d is equal to 0. If you have these two things, you can use the following equation to find the distance between the point and the plane. The equation goes that d is equal to the absolute value of a times x0 plus b times y0 plus c times z0 plus d, absolute value of all of that, divided by the square root of a squared plus b squared plus c squared. And this formula should look very familiar to you. It looks very similar to the equation we use to find the distance between a point and a line in 2 dimensions. So a very similar looking equation. Now all we have to do is plug those values in and then do our calculation. So let's say, for example, we have the following scenario. Take a look at my drawing again. And let's say this point P is at 1, 2, 3. That's point P. And we have this plane. And this plane is really just the plane Z is equal to 0. That's what this plane is called. Now, if you write it out so that all the x, y, and z terms are there, you could really call it 0 times x plus 0 times y plus 1 times z plus 0 for your d value is equal to 0. You could write it out like that if you wanted to, but in reality, it's just z equals 0. It simplifies to that, right? So you don't have to write it out this way, but it is nice because then you can remind yourself what your a, b, c, and d values would be in the formula, right? So you take your formula, it says distance is equal to a times x0, so 0 times 1. Okay, we can write that out, 0 times 1, plus b times y0, so 0 times 2, okay, plus c, which is 1, times z0, so 1 times 3, plus the d value of 0. You take the absolute value of all that, and you divide it by the square root of a squared plus b squared plus c squared. 0 squared plus 0 squared plus 1 squared. If you do all this work, on the top here, you should get a value of just 3. On the bottom, you get a value of just 1. 3 divided by 1 is 3. So the distance is equal to 3. Very simple calculation. Now, if you look at my drawing over here, you can note that, yeah, the distance here is in fact 3. It starts this vector at the plane, and it goes up to a height right here of 3. Now, this is very obvious looking at the picture because, again, this plane is a very basic plane that exists on the XY plane, right? It's a very basic looking plane, but they don't all have to look like that. For example, if I remove that plane there, you could have a plane that looks more like this, okay? And if you have a plane that looks like this, you now see that, okay, the distance is a little bit harder to judge with the naked eye, right? But we can still figure out what that distance is. We would do the exact same process. In this example, the point is the same point from before. It's still the point 1, 2, 3. But now the plane we have is actually 1x plus 4y plus 1z plus 5 is equal to 0. That's the equation of this purple plane. So again, we use our equation. D is equal to a times x naught, so 1 times 1, plus b times y naught, so 4 times 2, plus c times z naught, so 1 times 3, plus d. This d value, which is 5. Take the absolute value of all of this, divide it by the square root of a squared plus b squared plus c squared. 1 squared plus 4 squared plus 1 squared. Okay? And if you do this entire calculation, you should get approximately 4.07. Again, I rounded my answer. It's not exact, it's just an approximation, but that's the approximate distance between this point and this plane. And again, that's the shortest distance possible between them. Hopefully that process makes sense.